Welcome to Bellwork, Week 8, Day 3. I'm Mr. Schmidt. Let's get started. So our first question is, what factor about the atom led J.J. Thomson to conclude that if the atom contains a negative charged particle, that it must also contain a positive particle? So let's say we have a negative particle. I'm going to use a different color. I'm sorry about that. Let's say we have a negative particle, and that's all we had in the atom. Then our atom would have a negative charge. But that's not what we knew about the atom. The atom actually has a neutral charge. So what you have is a negative and also a positive. And so when you have a negative and a positive, they will cancel each other out. For instance, if you had something like 1 minus, and you also had plus 1 positive. Well, your answer is going to be 0, or what we say neutral. All right, so it's going to have a neutral charge. So if you have something negative, there must be something positive so that the overall charge is 0, and he knew the overall charge was 0. And so anytime you have a plus and a negative, they are going to cancel each other out, and so you will have a charge of 0. Let's say you have 2 positives and 1 negative. What's my overall charge? My overall charge is going to be positive. Let's say I have 1 positive and 2 negatives. Well, then my overall charge is going to be negative. All right, and you can see this because these are going to cancel out. These are going to cancel out. You're left with a positive, and you have a positive in your answer, right? You're left with a negative, and you have a negative in your answer. So if you have something that is positive, if you had something that is negative in the atom, then there must be something positive if the atom is going to have a 0 or neutral charge. Okay, and so that's all there is to that. And I'm going to post a quick answer for you to view so that you can check your answer. And let's go ahead and insert that right now. And that is not it. Okay. Okay, let's change a couple things. Sorry about that. Let's get this in here. Okay, this should work. Paste. All right, and performing the cathode ray experiment, J.J. Thomson discovered that all atoms have negatively charged particles called electrons. Because the atom has a neutral charge, or a charge of 0, there must also be a positively charged particle in the atom. So that's how you would answer that. I want you to put that in your own words. Your response should not be identical to mine, but it should have the same components. Now, we go to question number 2. What factor about the cathode ray experiment led J.J. Thomson to conclude that all atoms contain negatively charged particles? And the key part of this question is this word all. All right, how do we know all atoms? How do we know all atoms contain negatively charged particles? All right, and so J.J. Thomson used this cathode ray, and he used different metals in the cathode ray to produce the stream of light, all right, or the ray. The stream of electrons is actually what it is, the stream of electrons. And so because he used different metals, and each time it produced those electrons, he concluded that no matter what element I use, these electrons are produced, so that means all atoms must have these negatively charged particles, or all atoms must have electrons. And so to show you a written answer of that, I'll put that in here, and then I'll ask you a couple questions, and I wish you the best in answering those. Let's go over this. J.J. Thomson used electrodes made up of many types of metals to produce the stream of electrons in his cathode ray experiment. Because electrons were produced regardless of which metal he used, he reasoned that all atoms must contain negatively charged particles. All right, so your questions are coming up shortly. Good luck. Thank you for watching. Please tell your friends, and we'll see you tomorrow.